Alright, students, we are going to continue and finish this proof of the chain rule. So we got up to this point where we have that the derivative of a composite function, h of x equals f of g of x. And we did some fancy tricks by multiplying by 1, and we made it down to this place here where we know that the derivative of g prime is in there somewhere. And now we are going to proceed, and I'm going to take a little bit of a side note, and what we're going to do here is kind of a weird trick that's called creating an equivalent limit. So the idea is I take this limit up here and I create a limit just like it that behaves almost the same way, and by using a different limit that will allow me to solve this problem easier or more easily. So I'm going to define a new variable, k, and I'm going to say that k is equal to g of w x plus w minus g of x. Okay, and that essentially means that if we add g of x to both sides, k plus g of x equals g of x plus w. Okay. So I can define k as this term right here, and if I add g to both sides, then I get this little equation. And each one of these versions will be useful to us very, very shortly. Okay. So now if you notice here that as x approaches 0, so as x approaches 0, g of x plus w also approaches, so g of x plus w approaches g of x. And what that means is that k also approaches 0. Okay, so as this term here goes to 0, you end up with g minus g, which is equal to 0. So this is the part here that's very useful, and I'm going to take advantage of that to simplify this process. So now we go back to this limit up here, and what we're going to do is just rewrite everything. Rather than saying the limit as w, I don't know why I said x here. This should have been a w. I'm sorry about that. As w approaches 0, g of x plus w approaches g of x, k approaches 0. So up here, instead of saying the limit as w approaches 0, because these two are equivalent, I can say the limit as k approaches 0. And well, instead of f of g of x plus w, notice that this term in here and this term right here are the same, but that's just equal to k plus g of x. So this is f of g of x plus k minus f of g of x, so I'm going to leave that alone. All of it divided by this term, g of x plus w minus g of x. But this right here is the exact same thing as this, which is really equal to k. Now, this may seem weird and crazy, but it's totally mathematically correct. If you follow all the little steps, you'll see that all the little steps check out. That means the entire proof must also check out. And I know you may not be able to put the entire picture together, but this is part of the beauty of math, is that you could build up with tiny little small statements that somehow come out to have a very useful result. And I'm not going to forget the g prime of x that we had from up here. Okay. But now, if you look at this term, okay, so if you look at just this right here, this is the derivative. this is the derivative term, except instead of having x, you have g of x. So this right here is effectively the derivative of f with respect to g times the derivative of g. Okay. So h prime of x is equal to exactly this. And this is a very special result. This is something called the chain rule. Okay. And it's a good way for us to figure out how to take the derivative of composite function. So let me illustrate with just one small example, and then you can look at the other videos for the more complicated ones. Okay, so I have an example here. H of x is equal to sine of x squared. So the derivative of this is equal to, and notice here that f is the outside function, which is sine, and g is the inside function, which is x squared. So first we take the derivative of the outside function, which is cosine, leaving the inside function alone. Okay. So this part right here is f prime g of x, okay, times the derivative of the inside function, which is 2x. Okay. So this part right here is g prime of x. And there you have it, a proof and a simple little example of how we can use the chain rule to find the derivative of a composite function. So I leave it here. Look at the other videos for some other scenarios, some more complicated ones, but the general rule is what we have here. Thank you for watching, and have a wonderful day.